When we did it in the last class, we saw orthocenter inversion. In orthocenter inversion, I told you guys there are like two kinds of orthocenter inversion. The one we saw was this is a triangle. This is orthocenter on this. Then we invert at A with radius A root AH into AD. Okay, this was one kind of inversion. Another is we invert with center H like the orthocenter only with radius minus root H into HB. I don't care, it's imaginary or whatever, it's fine. So why is this a minus? What does this minus mean? Can anyone tell me?
Due to like that directed line.
Okay, no, we don't take directed lens. Any other reason why you can think of a minus possibly? Wait, this is directed though. No, directed lens makes it more complex actually. Well, let me think. Yeah, fine. Yeah, it's directed only. Yes. Okay, but fine. If I don't, even if it's directed, what does this minus signify? Okay. What will be the inverse of A, Anurag, or anyone basically?
It will be like D.
Correct. So when you take inverse of A, HA into HA dash should be minus HA into HB square root of this thing. HA cancels out. So HA dash should be equal to minus HB.
Isn't this inversion minus root HASD, not root minus HASD? Because that does make sense.
Like even if it's minus, if you square
Yeah.
it, the minus vanishes.
Squaring gives the same result, same thing.
I mean, that's kind of different. Like it's followed by reflection, if I remember right.
Yeah, I want that only. But okay, instead we don't. Yeah, sorry for that. Okay. Fine. I'll have to look about this directed lens stuff. We don't take the negative. Instead, we can do one thing. As Amish said, I guess we can define it as inversion centered at H with radius root HA into HB followed by reflection over H. Okay, so now when you take inverse of A, after doing this inversion part, this much only, it will be inverse of A is a point A dash such that HA equal to HB, HA dash equal to HD, right?
Reflection.
Say again, Anurag.
D would be the reflection along the H.
Ah, yes.
Yes. Now we reflect it over H, so A dash goes to D. So after doing both these things, the image of A is D. So basically this thing is composition of two functions. Reflection composed over inversion. Okay. I'll just call the point as inverse only. It means the point after you do both these functions. Okay. So what will be the image of F now?
It will be reflection of C along H.
Image of F after doing both these things. After inverting also and then followed by reflection.
Image of A or F?
A. Oh, sorry, F.
F will go to C.
Right. Do you understand how? Not just because
Yes.
of like.
Like
Yes.
HA times HD equals HF times HC.
Yes.
Yes, yes.
So after inversion, it will be a reflection of C over H. And now after doing this reflection, it's just C. Right. Also notice that whatever this preservation things we did, like someone asked it out before the class, right? First, notice that everything is preserved in inversion, like cyclicities, intersection stuff, and they're preserved in reflection also, right? So they'll be preserved in their composition also. So let's say omega is a circle. After doing inversion, it's another circle. After doing reflection of this thing, it's also another circle. So after doing reflection and inversion, it should still be a circle only, right?
Yes.
Nice. Similarly, intersections also you can replicate this proof. Okay, A goes to D, F goes to C, B goes to E. Where does circle BFEC go to?
It goes to itself.
Right. Does everyone see that?
Yeah.
Yes.
Nice. AEFH, where does this circle go to?
It goes to a line through here.
Line.
FE.
What's the line BC?
Someone says FE,
Oh, yes.
someone says BC.
Yeah.
Okay.
Yeah,
Oh, sorry, it will be BC. BC.
Right. Okay. BC. Everybody sees this, right?
Yes, yes.
Because see, it's a circle passing through the center of inversion, so it should be a line only. And since it's a line after inversion, after reflection also it will be a line. So F goes to C, E goes to B, A goes to D. So it's line BC. Okay. What else is there in this figure? Okay, HM point, I'm not sure. Let's try to find the image of HM point. Let's say this is HM point. What will be the image of HM point?
Dumpty.
Huh?
Do you mean Dumpty?
Humpty. Like the point which we did in last class, right? Image of HM point.
Can you define Q?
Okay. So AM is the median. Q is a point such that HQ is perpendicular to AM.
It would go to M.
1 second, Anurag. So who asked the definition of Q? Is it clear?
Yes, it's clear.
Also, one more fact. Clearly, Q lies on the circle AFE, right?
With diameter H.
Yes. Q also lies on circle BHC. If you want to prove, you can try inversion at A with radius root AH into AD. Okay.
Okay.
Nice. Yeah. So like for now, just assume this is true. Yeah. Anurag, go on.
Like then Q would go to M because of the angle condition.
No, Q can't
No.
go to M. Q should
Yes,
go
yes.
on to a point lying on HQ, right?
Yes, yes.
And it will also lie on FE. And it will also lie on BC.
Why FE? Yes, it lies on FE, it lies on BC. Yes, correct.
So those three lines are concurrent.
Yep.
It's a nice proof of concurrence, I guess.
Yes. Also, it can, this proof of concurrency can just be done by what do you say? Radical access.
Yes, radical access one.
You can take these three circles: HQDM, BFEC, and AEF HQ.
Yes.
Okay. For this inversion proof, so notice that Q is intersection of BHC with AFE. These two circles. Image of AFE is BC, so Q dash will lie on BC and image of BHC is just FE. Should will lie on FE also, right? Moreover, image of Q should lie on the line HQ, obviously. So HQ also. So these three are concurrent, and that's the intersection point. Is this clear?
Yes.
Okay. One second. Let me think. Where does the circle ABC go to? The circumcircle.
It goes to the 9-point circle.
Yes. How?
Like A goes to D, B goes to E, C
Yes,
goes
correct.
to F. But I guess the same inversion hold in by taking the inversion with center A with square root AH into AD. But it wasn't the 9-point circle, I guess, because A wouldn't go to D. A would go to
Yeah,
the point.
ABC goes to BC.
Yes, yes.
ABC goes to BC only. No,
Yes.
ABC goes to FE. Because B goes to F, C goes to E. So circle ABC will go to line FE.
Yes. So it contains the point of infinity.
Point of?
Point of infinity because like A would go
Yeah,
to
point of infinity is not a concern. Like you just say with the two other points of the circle.
yes, yes.
Okay. So this is a bit messy figure, but let's say I define this point now. Okay. So now I introduce our, what do we say, circumcircle also, and ABC intersects AFE in a point P again. What will be the image of P? If anyone gets the answer, don't speak it out loud. Send me
Okay.
private. Yeah. Send, you can send me in the like private chat also.
What's the question?
We are doing this inversion centered at H, radius root H into HD, followed by reflection over H. Now, if I consider P as the spiral similarity, like Michael point of BFEC, what's the image of P?
Like you are not doing any problem.
You are?
You are not doing like any problem or something.
Not yet. I'll first do this thing and then root BC by 2. Then I'll discuss one or two problems because I want to cover root BC and root BC by 2. That's more important. Okay. Shaurya got the answer. Did anyone else get it?
Yes.
Okay. Send me on chat. Don't speak it out loud. Like send me on personal chat on the Zoom only. Yes, Sahid, it's correct. Arkadeep, it's wrong. But I see where you are making mistake. The idea is correct. Try again. What's the image of the point which you wrote? Anurag. Yes, Anurag. What's that point? Arnab, correct? Correct, Anurag. Nice. So everyone got it. Shaurya, you got it first. So would you like to say your proof?
P lies on circle ABC, which is going to the 9-point circle. And P also lies on circle AFHE, which is going to line BC.
Yep.
So the image of P is on line BC and lies on the 9-point circle, and it is not D, so it is a midpoint.
Yes. Why it's not D?
Because A goes to D.
Yes, correct. Everyone clear with that proof?
Yes.
Yes.
Argadi, we were making the mistake. You figured out, right? How?
Yes.
Yeah, that's fine.
I forgot the image of it.
Okay, no worries. So everybody clear with the, oh no. Everybody clear with this inversion, right?
Yes.
Okay. Now I'll take a poll if people want to see root BC or root BC by 2 first. Let's see.
I'm really leaving this class as this 50-50 happens again.
Oh no, that would be bad.
I'm just joking.
We'll just
Ask-
in support of like something at the end. Like,
Wait, Shivayu, can you say it again?
I will just vote on one of the things if it's like 50-50.
You can't see it. Like after results, you can't vote. So how will you like get
Yeah,
that
yeah.
it's
Okay, I can't see that.
1 second. I'll create the poll. Uh, okay, people, you can answer now. Okay, there are 11 people, okay, but it includes me. So- Oh, nice. This time, only one thing is winning. 5 more people, I'll wait for a minute or so. Okay, 2 more people. 1 more person. I'll wait for like 10 seconds. If they don't answer, it's fine because whatever
Like-
they answer, the result won't change.
because like we have odd number of participants.
Yeah, yeah, yeah. But whatever the person who is remaining answers, the result won't change. Let me see. Okay, fine. I'll stop the poll now. You guys can see the results. So root B set is. Okay. Shall I do it on GeoGebra or Miro? I'll do
Like
Miro.
would be nice.
Huh?
GeoGebra would be nice.
Sure. But it will take me a minute to make a figure.
Okay.
Why is GGB worsening over every update?
Like literally just use 5 or something.
Use what?
Just like,
You can use the classic version.
like GGB 5. Who uses the latest version?
Ah.
Works like a charm.
Oh God. What's this scam name?
The inverse function. I didn't know this. Does DGB took the inverse function?
No, no. Or possibly. I'll have to check. I've never checked it myself.
Apparently, Baiju's like bought them.
Yeah, that's like very bad. Stop, man.
Imagine if you get okay. I don't know what's in it. So,
Oh God, this is so bad. I can't take a square root nicely.
okay, just like click on the keyword.
Finally. Okay, so I'll first define the root BC inversion. Root BC inversion. Inversion centered at A with radius root AB into AC followed by a reflection over angle bisector. Take a minute to grasp the definition, and if you want to note down, you can note it down. Let me know when it's fine.
What do you mean by followed by a reflection over angle? Oh, okay, got it.
Just
Yes.
like in the last inversion, we did a reflection over H. Here
Yes.
it's reflection. Yes.
Okay, got it.
Okay. Everybody got it?
Yes.
Nice. Okay. So let's move to here. Okay. Why do you think it's nice? Can you see any nice property like directly?
B goes to C, C goes to B.
Right. Okay. So image of B. Let's talk about image of B. Before reflection, like after just doing the inversion step, it is a point on AB, say B dash, such that AB dash equal to AC, right? So like in this thing, if I reflect this over this, you get a point B dash, right? Do you see AB dash equal to AC, right?
Yeah.
Now, if I consider the angle bisector, and reflect B dash over angle bisector, where will it go? See?
Yes.
Because like AB dash C is an isosceles triangle, and this is basically like the altitude also. And if you're reflecting it over this, it will go to C. Altitude and passes through midpoint. Right. Okay. I should delete this. Okay. So B goes to C, C will go to B. Where will circle ABC go to?
Line BC.
Line BC.
Correct. So, okay, I'll write all the results which you get here. B goes to C. B and C go to each other. Circle ABC will go to BC. Okay. What else was there? I forgot. Okay, where will the in center go to?
The AX center.
Who said it?
Sure, yeah.
Okay. Yes, that's correct. Anybody else who sees it? Why? I'll wait for a
Yes.
minute to so that you can try. Yes, Anurag, go on.
Like it will lie on the line AI. I'm pretty sure, because the reflection of that point along line AI will be itself.
Yeah, I will lie on AI even after
Yes.
reflection. But why does it go to X center?
Like just consider like AB into AC is we need to prove that AB into AC is equal to AI into AI A.
Yeah.
And just know that IA is like the reflection over the circumcircle of I.
Circumcircle of I.
IBC. ABC.
Oh wait, does that work as a proof?
Right now I'm complicating things, right?
Probably. It's just basic similarity.
Yes.
Okay. So you can just prove triangle ABI is similar to triangle AISC, and then show that AB into AC. For those of you who didn't get, triangle ABI similar to triangle AISC. This is angle chase. This is angle beta by 2. This is alpha by 2. Alpha is like, okay. Sad. Sad by you. It's just because my hair looks bad whenever I take a bath until they like dry. This is A by 2, this is B by 2, this is C. This angle is 90 minus C by 2. So you'll get this angle is B by 2. So ultimately you get this thing. Do people see how? Hello people, I'm talking to you.
Yes.
Yes.
Yeah. And then this follows by similarity. So AB into AC equal to AI into AIA. So like after inversion step, I will go to IA. And if you reflect IA over the angle bisector, it will go to itself because it lies on the angle bisector, right?
Yes.
Cool.
We could use this also as a proof. This circle.
BICIA.
Yeah.
Okay, how?
Because say M is the point where AI meets the circumcircle of ABC, then M is the center of this circle.
Right.
And so with the help of this, we can see that circle BIC intersects AC at say B dash, then B dash is the reflection of B about AI.
Wait, can you say that again?
If you consider the point where BIC meets AC, that point is the reflection of B in AI.
Yes. Okay, so
power of point.
Oh, right.
Power
right.
of A. Yeah.
I see. Yes. Yeah, actually, like the intended proof was this. Like, not intended, but like when I read it in a book, this was this. But like I presented this earlier to some of my friends, so I remembered this one, which I just said. Also, like, oh wait, let me check if these two circles. Oh yeah, we can also do this. Like this is the center. This is the center of this circle. What's this angle? This is 90 minus A. This is A by 2. Oh, these are not all broken. Yeah. Wait, this should be orthogonal. Oh, not this. Oh, fine. That will be a bit complicated. Yeah, okay, this works. Yeah, what Shaurya said. That also works. Yeah, undo until all these things go. Okay, apparently I have forgotten all the nice properties of root PC. No, Devayu, not that. Why are you in this class? You can leave the class. Thank you. Bye bye. Kidding, okay.
That was rude, okay.
I didn't. It was a joke. I'm so sorry.
I mean,
Okay.
this was nice.
No, okay. I take back the sorry. I was not. Bash is never nice. Even barycentric is not nice. Okay, wait.
Hey, but aren't you taking barycentric?
Yeah, like it's not nice, but I need people to know the technique. Like nice as in like I don't like bashing, but it's fine from contest point of view.
As far as I remember, you were bashing in Sunana's class for projective geo.
Oh, that was as a joke. I didn't mean it literally. Okay, people, let me recall the other properties. Oh God. Okay. Where will the midpoint of BC go to? I hope the value it's not due to me. But yeah, it's fine. Bye.
It would go to the intersection of AC median with BC.
Correct. I'll write it. I'll do this.
Like in general, any line goes to its isogonal line, right?
Yeah. Okay. Do people see how this follows?
Yes.
Nice. I'll still say it for sanity. If this is the midpoint of BC, then note that AM will go to the line, the C median line. Okay. Because like it goes to its isogonal line, right?
Yes.
And BC goes to circle ABC. So M lies on BC. So it will go to the intersection.
Yes. Yes.
Okay, there used to be very lots of nice properties with root BC. I can't recall them in the class.
The foot of the altitude going to the antipode and vice versa.
Photo of altitude goes to antipode.
It does not go to the antipode, right? It goes to the circumcenter.
No, that's in root BC by 2. Yeah, he's correct. Like foot of altitude.
Oh, right.
Oh, actually, I never thought of this. Like, I might have used it in a problem, but like I never remembered this as a property. That's nice. A antipode. See, we know that like this line is isogonal to the like radius, right?
Yeah.
Right. So like AD will go to line AO, and since D lies on BC, it will go to this. So A antipode. Okay. The 9-point circle is the image of 9-point circle. No.
The image of 9-point circle would go to like to the circumcircle ABC.
Yeah, the 9-point circle will go to circumcircle.
Because like every foot of altitude goes like A dash
Yes.
with A dash dash.
No, wait, that shouldn't be true. No. See, the thing is, if you take the 9-point circle, D lies on that, M lies on that. Okay. So
And
these
then
two,
the median
yeah.
and section of A, circumcircle A.
Yes.
So all that lies on.
No. Arey, listen, na. You have 2 points, but other midpoints don't go to that, right?
Yeah.
So you have 2 points on the circumcircle, but you don't have a third point on the circumcircle. That's BC. Image of BC goes to ABC, not the 9-point circle.
In fact, ABC goes to the mixed linear circle, right?
ABC? ABC goes to
not
BC.
ABC omega 9. No, wait.
Does it?
In circle goes to mixed linear in circle.
Yeah.
Oh, right. That makes sense. Yes. Okay, I was thinking about like X circle goes to mixed linear circle, but that was root BC by 2. Yeah, fine. How do I delete this? Oh, there's a eraser also. I never knew. Okay, so let's take the N circle. Oh God, what is happening? Wait, it doesn't. What?
This is like an external mixed linear in circle or something.
Yeah,
This is
right.
going to be tangent to AB, AC, and
Yes.
circle ABC.
Yeah, it will be tangent, but why is it not? Wait, then what?
So then the
what's the image of
then
mixed
the
linear?
AX circle goes to the A mixed linear in circle and vice versa.
Isn't that in root BC by 2?
No, it's in
I
root.
think in root BC by 2, you have in circle going to mixed linear in circle.
Yeah.
Maybe.
Yeah.
Okay, I always confuse this. That one. Oh, right. Yes, fine. Okay. Do I need to draw the X circle now? Let's do it the other way. No. Okay, I'll just give a qualitative proof. I won't be drawing the exact circle. It's too much work. Let's say this is the mixed linear circle. Okay, then notice that this thing, let's call it omega A. Omega A is tangent to AB, AC, and ABC. So, image of omega A will be tangent to what three things? Since it's tangent to AB, it should be tangent to AC.
AB, AC, and BC.
Yes, AB, AC, and BC. Which means it can be either the in circle or X circle, right?
Yes.
Nice. So now, thing is, if you see this intersection point, let's call it K.
The X circle would go to itself, right?
X circle?
X circle.
No.
No. Yes, we are. No.
Yeah. So if you take this mixed linear in touch point on AB, let's call it K. It's known that AK is less than AB, right? Because mixed linear circle is completely inside.
Yes.
So which means when you take the image of K, let's call it K dash. AK dash will be greater than AC because AK into AK dash is equal to AB into AC. So now if you take,
Lying on line AC.
yeah, it will be lying point line on AC. Yeah, but do you see why AK dash should be greater than AC?
Yes, sir.
Nice. So it means like it lies outside the segment AC. Similarly, the other in touch point, both of them lie outside. So like it can't be in circle, right? Because in circle, all the in touch points are inside the triangle. Right?
Yes.
So you get that it's X circle. Also, one more nice property here is if you take this mixed linear in touch point, let's call it X, and take the like X circle ka X touch point, let's call it D dash, then these two are isogonal. Do you see why? Because X will go to D, and since it X goes to D, those two lines are isogonal. Is it clear?
Yeah.
Okay, yeah, I think there were no more properties as such. Like fine, you can always find more things in the problems when you are doing it. Omega A goes to X. Let's see if I can find orthocenter. Do we know centroid? No, that will be a bad point. Midpoints are just like the
Where would the centroid go?
or where will what go?
Where will the centroid go?
It will go to the
It will be
intersection
on
of
the
same
AC
points.
median, and like if the AC median meets the circumcircle ABC at K, then AK is to K, G dash will be 2:1.
Yes. Sir.
I think it's that, no, like if you take the AC median and you consider the circle like will it be like that this tangents intersection, no? This point, image of G. Let's check. If omega A would have gone to in circle, then all the mixed linear in circles would have gone, which is not possible. That's not true, Sahid, I guess, because like here we are dealing with like acentric stuff. Like if let's say the other mixed linear in circle, let's take omega B, right? It's not necessary that it should also go to the in circle because uh, you're reflecting over A angle bisector, not B angle bisector, and stuff is like around A. So that symmetry won't hold. Yeah.
The point where the tangents meet,
Uh-huh.
like if you consider the circle through A and C tangent to BC, and the circle through A and B tangent to BC, the intersection of those 2 points will go to the intersection of tangents.
Circle through A and B tangent. That's also a nice point, right? That's I think Humpty point. Yeah, that's the Humpty point, right? Okay.
Oh.
Yes. Centroid goes to Simidian point. Really? I don't remember the centroid. Let's check actually. I
So
don't
see, midpoint is going to the point where the
technically it
AC
should go
median
to
meets the
the
circumcircle.
C-median.
So then, and AG is to G midpoint of BC is going to be 2:1. So you'd get the same ratio again.
like okay, fine. I see the ratio would hold, but is
Right.
AK into like AK by that point is 2:1? Is that 2:1?
Yeah, because if if the midpoint of BC is M, then AM into AK is AB into AC, and AG into AG dash is also AB into AC.
Oh, right. Yes. Also, Arnab, medians go to C medians. That's not true. Only the A median goes to AC median. B median won't go to the BC median. Do you see why? Because like the lines go to their isogonal lines with respect to A only. Yep. No worries. Okay. I still doubt. Like median point should be inside, right? It's not the median point. See? But it's something nice. I remember that. Wait, isn't this the reflection of the Dumpty point? Oh God, what am I doing? Sorry. Yes, it's this only. Wait, sorry, how did you get that?
Because if you consider the circle through, no, then you probably defined it differently. That point is not the centroid.
Oh, what's the centroid then?
Now, how do you define G?
Arey, Nelly, what's like the number of centroid?
Number meaning? No, I don't know.
See, it's centroid only. No? These are midpoints.
Is this some weird case where the centroid is also that special point?
Arey, see. Oh, yes. Wow. Centroid was the Humpty point in this one. Oh.
Does that happen if BAC is 60 degrees or something like that?
Possibly. Yeah, I mean it's 60 almost. I'll delete this. It's fine with everyone, right?
Yes.
Okay, let's try to find the image of centroid. This will be a nice exercise. Okay. We know it lies on the median. Let's take the midpoint of this. Oh, right. It's reflection over this. Can we prove this?
Wait, so if this AC median meets the circumcircle at K, then AD is to DK is 2 is to 1.
You mean AD is to DE?
Yeah.
Right.
Yeah. Is that 2 is to 1? I don't think so.
1 second, I need to drink water.
If G dash, if that's the reflection of D, if that's a reflection of A and D, then AD is equal to DG dash. And you also have that AE is twice of EG dash.
Wait, AG is twice of AD dash? What's the last thing you said?
I said AE is twice of EG dash.
What's
AE,
G? Yeah,
AE,
what's G dash?
G double dash. The
Oh, okay, all right. Yeah, it's
yeah.
2:1 according to this thing, but let me check. No, it's not 2:1. Oh no, it's not also the midpoint. It's just that weird case. Yeah, it's not the midpoint. Yeah, I don't see a better way than the ratio, which like Shaurya said, to define in that. Does this one lie on the second or the- Yeah, fine. Let's just stick with that. Let's just stick with that. The ratio thing. Is it fine? Okay. Let's move on to the image of this point. We already discussed it, but like I want to prove it also. What's the image of this point? D.
It's the empty point.
Okay, who said this? That means yeah, who said this? Amish, right? Okay, whoever said this, give me a proof. That's the whole point. I'll wait for 2 minutes. Okay, anybody else? Sure, you have a proof, right?
Yeah.
Okay, fine, you tell then.
So DB is tangent to circle ABC.
Yes, DB is tangent.
So if D dash is the image of D, then D dash C A.
Like, okay, what's the image of the tangent? Let's just go with that. What's the image of tangent?
It's the line perpendicular to BC at C.
Tangent is a line, image should be a circle.
Sorry, the circle through A and C tangent to BC.
Right. Do people see this? Why? If not, you can say no, it's fine, I'll explain. But I want to know how many people understand this. You can also type in chat. Okay, I'm back. Yeah, anybody? Like, if you say it, you don't say it, yes, no. Fine. Okay, so see, this is a B tangent, right? This is tangent at B. This is tangent to circumcircle ABC. So its image should be tangent to to image of this thing. The image of circumcircle is line BC. So it means this is tangent to line BC. It's a line, so it should be a circle passing through A. And since it passes through B, it should also pass through C. So that is why it's a circle through A and C, tangent to BC. Is that clear?
Yes.
Okay. Also, I'm getting a issue screen sharing. I'll start again. Syed, you are unmuted. Do you want to say something? Okay, the annotations are gone, but yeah. Okay. We have the image of this tangent and we have image of this tangent. So since D is their intersection, image of D will be intersection of those. Right? Is it clear?
Yeah.
Right. Okay. So what's the image I'll show with GeoGebra and why it should be the HM point? That's also a question, right? Oh man. Okay. So you see that G is the image of D, right? I assume that's a yes. Now we need to prove that G is the HM point. Okay, I also need to think of a proof. It should be angle chasing only, I guess.
See, it lies on the median that we can do.
Yeah, I got that it lies on the median. Okay, let's assume G as the intersection of median with this. Can we show this is 90? Okay, I think I have a proof in mind. Let me forget the details. Okay, so let's define G as, let's call the circle omega b. Let's say G is omega b cap am. Then angle GBM equal to angle BAM, right? Oh, but we don't have this then. Hmm.
Can you repeat?
So I was trying like if let's this and let's call this circle as omega b, and let's call them like let's define G as omega b cap am, right? Then we have that GBC, this angle equal to angle BAM. Do you see why? Like this is tangent, right? BC is tangent to this circle. And like if this was the HM point, we know that this angle is equal to this angle, but how do we show this now?
G is omega b intersection AM, right?
Yep.
Yeah, okay.
Oh, I think we can do it in a better way rather. So, yeah. Let's say G is the HM point. Let's call G, let's say G is our HM point. This is our orthocenter. Then we have that BHGC is cyclic, right?
Yeah.
So this angle is equal to this angle, right?
Yes.
And then we can show like that this angle should be equal to this angle, because then we'll be done. There should be angle size only. Hmm. The more concerning fact is I remember proving this, but I don't remember how I proved this. All right. Yeah, this works out now. Nice. Thank you. Okay. Yeah. So what we do is like we extend CH to meet this at F, then AFHG is cyclic, right? 1990. So this angle is 180 minus. Yeah. So is it clear? So like this angle is
What are
equal
you
to
saying?
this angle, and then this angle is equal
Your
to this
voice
angle.
is cracking.
Minus audible.
Yeah.
Yeah, mine better.
Your voice is breaking too much.
Yeah, I'm not speaking.
Oh yes, it's clear now.
Oh, it's clear. Okay. Okay. Yeah. So Arnab told this proof. Like this is a nice. So we need to prove that this angle BAG equal to angle GHC, right?
Yeah.
Because then G is the Humpty point. Because then GHC will be equal to angle GBC, and since this is, we get that this should be circle AGB is tangent to BC. So we will be done, right? Is this clear?
Yes.
Nice. So how do we prove it?
Yeah.
Extend CH to meet AB at F. Then AFHG is cyclic because 90-90. So which means this angle should be equal to this angle. Hence we are done. Make sense? Or is it that is this fine?
Yeah.
Okay. Yeah. Okay, I clowned really hard for this proof. This is what happens when you come to classes unprepared and at the last minute. Okay, so we are done with the root BC by 2 inversion, root BC inversion. Let's move on to root BC. Okay, just a moment. Everything is same, just the radius of inversion is root AB into AC by 2. Also, people are understanding, right? I was like stammering too much in the last thing, but you guys got right. Like, if you have any doubt, you can ask. Oh, wait, is my voice coming?
Yeah, you're audible.
Yeah, so in root BC by 2, everything is same, just the radius of inversion is root AB into AC by 2. So like if you find the image of B, then AB into
The
AB. Oh yeah, say it again.
reflection is the same.
Yeah, the reflection is same, but what will be the image of B?
The image of B will be
Midpoint
the
of AC.
AC.
Midpoint of AC, yes. Because
same
AB
goes,
dash, oh yeah, say it again, sorry.
same goes with C.
Yes. Because like AB dash equal to AC by 2 and B dash is the point lying on AC. So it should be midpoint of AC. So B goes to midpoint of AC, C goes to midpoint of AB. Where does the circle ABC go to?
The line HAB, HAC.
Oh, these are M by the way, not H.
And very
Like midpoint, right? Yeah.
yes,
It goes to the midline.
yeah.
Okay. What's the image of the circumcenter?
Foot of altitude.
Yes. How?
Because like in root BC, it was foot of altitude going to the antipode.
Yes. So we had that AD into 2R equal to AB into AC. So if we just take this to here, AD into R is just OA. So do you see why? And we know that AD and AO are isomorphic.
Yes.
This is Brahmagupta's formula, right?
Oh, something like that. I don't remember the name. Like Brahmagupta had some nice properties in like perpendicular stuff, so might be. But I don't
Yeah, I think this was the one. 2R into AD is AB into AC.
I see. Okay, what's the image of centroid here? What's the image of centroid? Anybody?
It's going to be on the AC median and that same ratio thing. We have to do
You
it
don't
through
need that.
ratios.
There's a better way to define. See,
Is
there's
it the
one more.
median point?
Is it? Doubtful, but let's check. I also am not sure.
It's going to be intersection of circles A, M, MABC and A, MAC, B.
Yes. That's the way I was looking for.
Okay.
No, it's not the median point.
When you have this cool ratio thing here as well.
Yeah, that would be true, right? Ratios are conserved, no?
Yeah.
Okay. Yeah. So what's the image? C. We can define centered in this way. CM, like this line will go to the circle A, MAB, C. Right? Similarly, this thing will go to circle A, MAC, B. So these two intersections. Whatever, this is bad. This. Okay, image of centroid is clear.
Yeah.
Nice. What else could be there? Okay, the 9-point circle. Where does the 9-point
Did you find the image of the centroid in root BC inversion?
Yeah. That was just by like the ratios.
Ah, okay.
Yeah, we didn't find like a nice one though. So yeah. Okay, where does the NPC go to?
Circle BOC where O is the circumcenter of
Yeah.
ABC.
Circle BOC. Because the A feet goes to the circumcenter. These two midpoints go to C and B. So you got 3 points. So it should go to this, right? Clear? Circle AOB. What's the name of the circle AOB? This also nice.
Line DMAC.
This line. Okay, yeah. These are some basic properties of root BC by 2. Okay, what are more properties? Yeah, that's it, right? With root BC by 2. It comes in play like
You
when
have in circle going to mixed linear in circle.
really?
Yeah. I think so.
One second. Yeah, fine. In circle goes to mixed linear circle. The proof is same as root BC. Just the fact is like everything will lie inside now. Right?
Yeah.
Like when you take the mixed linear in touch points, we had that this goes to outside, but now there is a by 2 factor, so it comes inside. Clear?
So it would be in circle.
Yes. Yeah, that's it. Okay, we are done with types of inversion.
Wait, it would just be the X circle. No, okay. No.
X circle
Okay.
is in root BC, right? It should be X circle or in circle. It can't be anything else.
Yeah.
Okay, guys. So we are done with the types of inversion. Now like it's like 9:30 and people have started leaving, sadly. So we can do two things. We can do the problems or we can just end the class. Whatever people want to do. I can discuss like 1 or 2 nice problems after taking a 5-minute break. Let's do a poll for this. Oh no, 2 more people leave. Let's you can answer the poll. It's fine. I won't mind if you want me to end also. It's fine. Okay, 2 people have answered. 2 more people. Fine, 3 people have answered for few problems. Let's do few problems. I won't be recording that. Let's just do it like group solve types. Okay, if that's fine. Hello.
Yes, that's nice.